Math 2312, Chapter 1, Functions, Section 1, Functions and Function Notation, Video 3, Function Notation. As we discussed in class Tuesday, function notation is basically, I don't want to say it's a formula or an equation, but it's almost a set of instructions saying, I want you to do something, and now I'm going to ask you what to do it to. Just remember that in function notation, the expression f open parentheses x is read f of x. The variable going in is called the input and is representative of the domain value, and the value coming out is called the output and is a value representing a range value. So the domain value goes in, the range value comes out. So for example, on this one, if f of x equals x cubed plus 2x squared, we're being asked to evaluate f of negative 5. As was stated in class the other day, this simply means that you replace the input variable, x, with negative 5 and evaluate. The safest way to pull this off is to rewrite the function, but change every x to an open parentheses. In this case, parentheses cubed plus 2 times parentheses squared, and then proceed to substitute the correct value. In this case, we're substituting negative 5 everywhere there's an x. By setting up empty parentheses, you're providing a space to insert the value while preserving the structure of the function. And then you just work it out. Well, negative 5 cubed is negative 5 times negative 5 times negative 5, which is negative 125, plus 2 times negative 5 squared is positive 25. And so if we multiply, we get negative 125 plus 50, and when we put all that together, we get negative 75. It's important to point out that when you evaluate a function, especially numerically, meaning you put a number in and you get a number out, you've actually generated an ordered pair. Keep in mind that the input represents a value in the domain and the output represents a value in the range, meaning we could write the combined input and output as an ordered pair. When we put negative 5 into the function, we got out negative 75. This function turned negative 5 into negative 75. A couple of things I want to point out. Number one, functions don't have to be called f, inputs don't have to be called x, and outputs don't have to be called y. For example, on this one, if g of t equals t squared minus 1 over t minus 1, evaluate g of 9. Mechanically, it works exactly the same. Simply substitute 9 for all of the t's, and you get g of 9 equals 9 squared minus 1 over 9 minus 1. In the numerator, 9 squared is 81. 81 minus 1 is 80. The denominator is just 9 minus 1, which is 8. And in this case, we have a fraction, which you should always ask, can I reduce it? And sometimes you can flat out divide it. In this case, 80 divided by 8 is 10. Now, does that represent y or some other letter? Well, without a context, we really don't know what variable would be representing the generic output. It's safe to assume it's a y, but then again, the input wasn't an x. Regardless of what variable the output is representing, it is an element in the range, meaning that we could create an ordered pair for this function by saying when we put in 9, we got out 10. Sometimes, however, the things you substitute into a function aren't numbers, but rather other expressions. For example, if h of z equals the square root of 9 minus z, let's evaluate h of w minus 1. When you're substituting an expression like w minus 1, as opposed to a constant like 9 or negative 5, that's a really good time to do the empty parentheses approach, meaning that you write the function, but replace each occurrence of the input variable, in this case z, with an empty parentheses. So under the square root, instead of 9 minus z, I'm going to write 9 minus empty parentheses. Then proceed to put the correct input in the parentheses. In this case, the correct input is w minus 1. Now, unlike numerical inputs, expression inputs usually don't simplify to a single value, but rather another expression. How far do you push it? A good rule of thumb is push it until there's nothing left to do. If there are parentheses that you can get rid of, you may want to consider that. If there are like terms to combine, you should consider that. But once you're out of things to do, you should usually stop. In this case, we have the parentheses around the w minus 1, which we got when we replaced the z with empty parentheses, and this parentheses has a minus in front of it, so the negative will get distributed and change the signs of both terms in the parentheses, meaning that we have a square root with a 9. The minus distributed to the net w gives us a negative w. The minus distributed to a negative 1 gives us a positive 1. And by busting open the parentheses, we've exposed two like terms that we can now combine. The 9 and the plus 1 is going to give us a 10. So we could write the square root of 10 minus w. We could also have written the square root of negative w plus 10. Could we write this as an ordered pair? We could. It would look funny. Excuse me, or the hiccups. The input in this function problem was w minus 1. The output was the square root of 10 minus w. This isn't an ordered pair. We could go up to a coordinate plane and locate it, go over and up and put a dot. But you could think of this as an ordered pair generator, meaning I could substitute any number for w, work out both of these, and then we have an ordered pair. Well, I say substitute any number for w. This function actually has domain issues. In other words, numbers that we can't put into the function and expect to get a real number out. If you think about it, there are some numbers that would cause trouble if we substituted them here for z, or equivalently substituting them there for w.